Hi everyone, I am Geetha, Assistant Professor, Department of Mathematics, SNS College of Engineering. In this session, we are going to discuss about applications of Markov process in engineering field. What is Markov process? Markov process is a stochastic model describing a sequence of possible events in which the probability of each event depends only on the state attained in the previous event. It is widely used in various engineering fields. Basics of Markov process. Transition probabilities. Markov process is characterized by transition probabilities determining the likelihood of moving from one state to another. Memoryless property. Each state's future behavior is independent of its past, making it is a valuable tool for modeling dynamic system. State space, the set of all possible states of the system. It can be finite or countably infinite. Applications in electronic engineering. Circuit design. Markov processes are applied to model the behavior of electronic circuits with state dependent transition. Fault tolerance, used for analyzing the reliability of electronic system and predicting failure probabilities. Applications in communication engineering. Data transmission. Markov processes help in analyzing and optimizing protocols for data transmission in communication system. Network routing. Used for modeling routing behaviors and packet switching in communication network. In wireless communication system, Markov models are used to analyze the behavior of wireless communication channels. For instance, in fading channels, where the quality of the received signal fluctuates over time due to factors like multipath propagation. Markov models can be employed to characterize the channel's state transition. This helps in designing efficient communication protocols and error correction techniques. In network protocol analysis, communication networks such as the Internet of Wireless Sensor Networks often experience dynamic changes in their conditions. Markov models can be utilized to analyze the performance of network protocols by modeling the states of the network. For example, congestion level, packet loss rates, and transition between them. This aids in optimizing protocol design and resource allocation. Example 1, Markov chain in signal processing. Noise filtering. Markov chain are employed for signal processing tasks such as removing noise from transition. Speech recognition, used to model and recognize speech pattern in communication system. Data compression, applied to compress and efficiently transmit data without loss of critical information. Example 2, Markov processing in wireless network. Handover processes, utilized to model and optimize the handover processes in wireless communication. In network resource allocation, assist in efficient allocation and management of resources in wireless network. Error controlling. Error control coding techniques such as convolutional codes and turbo codes rely on the concept of Markov process. These codes exploit the memoryless property of Markov process to efficiently correct errors introduced during communication over noisy channel. And channel modeling and equalization. In digital communication system, especially those employing modulation technique like Gaussian minimum shift keying or quadrature amplitude modulation, Markov models can be used to characterize the behavior of communication channel. This facilitates the design of optimal equalization technique for mitigating indecibel interference and other impairments. Coming to the conclusion and future development, advancements. Continuous improvement in computational capabilities enable more complex applications of Markov process. Emerging technologies, integration with AI and machine learning leads to innovation in dynamic system modeling and prediction. Thank you.